we can get started nice and slowly. The rest will join us on our way. First of all, thanks a lot for joining. For everybody who is online, we are excited to share this moment together with you. I will start off by introducing myself. My name is Louis Larson. I am a Hubgrade Performance Plant expert and business development manager here at Veolia Water Technologies. I have been with Veolia company for the past 7 years. And for the past 5, I have had the pleasure of working with our digital technologies, namely the solution that we will introduce today. I have a background as a chemical engineer, and so I've done a bit of everything from commissioning at client sites to process and performance audits, and now taking care of this digital product. It's great to have you all on board. So today we're going to talk about real-time predictive analytics and how to leverage that with process optimization for environmental footprint reduction and OPEX reduction. That's going to be really good. So if there's one reason to stick around on that, is that a little bit later I'll tell you about how we managed to save a customer around 3 million euros in OPEX and reduce their CO2 emissions by about 1,700 tons of CO2. So that's worth the wait. So without further ado, let's get going. I would like to start on something that is a bit maybe a bit more generic for everyone, but nevertheless make sure that we all live in the same reality. So I want to share with you some of the challenges that we typically encounter when we are talking and dealing with our different partners and customers and colleagues around in the industry in wastewater treatment. First of all, and I'm sure you're all aware of that, well, regulation and compliance at the moment are two topics that really are overarching and everywhere, especially the new EU Urban Wastewater Directive. This is the first new version since '91 and has a lot of important elements that clearly make it a lot more strict and a lot more difficult in terms of nutrient removal and with the new dimension of the energy neutrality. So we're encountering a lot of that. Also, this theme around population density and urbanization, that means that wastewater treatment plants around the world now have to handle larger volumes in terms of amount of pollution, but also in fluctuation, and can face challenges in terms of meeting that growing demand of treatment. Finally, under that, also the theme around expansion of treatment facilities, process intensification, footprint expansion. So is there actually space to expand that plant where it is now compared to the city around, etc.? Those are some quite interesting topics. And finally, unfortunately, we see the effect of climate change more and more every day. And wastewater treatment plants are definitely not the lasting class to have to fight that, to be resilient against that, and to be able to mitigate the impacts of the extreme weather events that we notice. And so what does digital have to do with all of this? Well, we actually think that there is quite a bit it can do. It can be an inherent part of the solution to some of these challenges, and that's what I want to talk to you about today. Here at Veolia, we've chosen to call all our digital solutions Hubgrade. So that's what Hubgrade is very quickly. It is Veolia's global digital offer. So that's comprised of a wide and flexible range of different solutions that address the needs of operators, of managers, and other stakeholders around the wastewater treatment industry. It is a way for Veolia through a platform to leverage its know-how in the field, being the leader of the ecological transformation with all the experts that we have, and especially to leverage this digital technology. Now, let's focus on the topic of today, which is inside all of these digital solutions. One of them is Hubgrade Performance Plant module. And the Hubgrade Performance Plant module is, in essence, the digital twin of Veolia. I also like to call it your digital twin, or because it is something that has been made and developed together with customers, real wastewater treatment plant operators and utilities. And digital twin gets thrown around a lot at the moment. So what is it exactly? I'll try and give what is our definition of it, at least. You have the real world, and that's a physical plant where you have a SCADA, you have a PLC, there's operators running around handling all kinds of problems and making sure everything runs smoothly. A whole team around that. You've got meters, set points, and basins, and of course wastewater. That's what the plant part is, the real world is. A digital twin is, as its name is, a digital representation of that. And for us, it is a bit more than just a digital representation. It is a real-time representation of that. You need to have it connected to the reality and as close to reality as possible. Now, how do we do that? Is that we like to transfer data from the real assets to its twin, to its copy in the digital world every 2 minutes. In that way, you can start performing simulations, you can apply know-how on it. So Hubgrade Performance Plant is lodged on this digital twin and can apply its optimization effects on the data and then send it back to the real asset. So being really connected in real time to the plant by sending optimized operational set points to it. And this is something that's set at 2 minutes, which could be a set point on an amount of dosing or an aeration level of DO. And that's basically how we define digital twin and what is the essence of Hubgrade Performance Plant. Now, what kind of intelligence do we apply to this data? What does Hubgrade Performance Plant leverage as a digital twin? What we like to apply to it is a combination of know-how and digital technology. On the one side, you have the white box or rule-based know-how. So these are a set of predefined rules and logics intrinsically linked to the process expertise in wastewater treatment from Veolia's numerous years of operations around the world in contact to clients. So this could be process data guiding different decision-making in terms of an aeration level, for example. And then we want to apply and use, which we've done for some time now, the principle of AI. We're more and more exposed to it. And what we've done is that we've tried to combine these two worlds over the past years, applying machine learning and neural networks and data analysis so that we can enhance the white box through the black box model and have a better decision-making process. So if you mix white and black, what do you get? You get gray. And for us, that's what we like to call model predictive control or gray box modeling, and is to us the most robust form of decision making in terms of control optimization actions. A model predictive control algorithm is able to combine the historical data, so the AI part, with the biological mathematical models that are in play in the white box and in the wastewater treatment industry. By combining those two, we can start predicting the behaviors of the system and thus make the best choice for operation on it. And that's exactly the type of intelligence that we leverage with Hubgrade Performance Plant and the digital twin. Now, altogether, what does that mean? It means that the Hubgrade Performance Plant module is your digital twin that can help you to optimize your energy savings, your OPEX, your effluent quality, your hydraulic capacity. It can even be your greenhouse gas emissions. So say that you are looking to reduce your environmental footprint. Then you can choose to install a digital twin like Hubgrade Performance Plant to target this GHG emissions, for example, the nitrous oxides emissions that are a normal part of the biological process when you're treating nutrients and nitrogen. This quite dangerous actually gas, nitrous oxide gets emitted, and that has a high global warming potential. So you could choose to install Hubgrade Performance Plant to reduce that, or to make savings of chemicals, or to make sure that you can treat even more water by combining your sewer system and your wastewater treatment plant in a holistically optimized wastewater system. All of these contribute to your OPEX, to your treatment capacity, and to your environmental footprint. And that's what such a technology enables you to do. So that's all in well, but let's try and take a step into the real and show you what kind of results you can expect using such a system. So first we're going to Italy. The plant is called Nosedo Wastewater Treatment Plant. It's located in Milan. It is part of the public utility there in Milan, and the public utility there is responsible for providing water and wastewater treatment to around 1.25 million people. This specific customer was faced with a couple of challenges, some very close to the ones named earlier: fluctuating loads, stringent requirement, especially because here, and that's a great thing, they are reusing all their water for agricultural purposes, so treatment is really an important factor. As any public utility and pretty much everyone, OPEX is always in focus, and reductions are always welcome and looked for, as well as being interested in reducing the overall environmental footprint. Now, they've been running with the Hubgrade Performance Plant for 3 years, and here are some of the results they've seen. They've been able to reduce their OPEX for the biological treatment by 24% in average over the past 3 years. They have reduced by approximately half their dosing of coagulant for phosphorus precipitation. So that's a really strong impact on the bottom line in the OPEX. But it does not come at the cost of treatment quality and compliance. And that's something I want to highlight, because in fact, when you look at their effluent concentrations through the 3 years of running with Hubgrade Performance Plant, you see that their total nitrogen in the effluent has gone down by 30%, and that their total phosphorus concentration has gone down by 6%, which means that actually treating better goes hand in hand with treating more efficiently. That's maybe even a part of the definition of an optimized system. By reducing their electrical consumption, their chemical consumption, and their treatment and effluent quality, they've been, in average, able to avoid 1,700 tons of CO2 per year since then. So that's a real difference in terms of the environmental footprint. They are also able to handle 20% more load through their plant in stormwater events, in peak flow events, thanks to a more dynamic handling of the process. And as teased a little bit earlier, all of this, to give a concrete number, all of this amount to, in the 3rd year of operation of Hubgrade, the savings amount to roughly 3 million euros. I'm the one telling you this, but maybe it's even better to hear it from the customer. So I'd like just to share this little video with you of our customer in Milan talking about Hubgrade Performance Plant.
Increasing the level of real-time water quality monitoring system coupled with a smart management system was the key. At Nosedo, in fact, within last year, we achieved some important targets. For example, we were able to reduce by 25% the specific energy consumption for the biological treatments. We were able to improve the phosphorus removal via biological way with near zero chemical consumption. And very important for the Italians, we were able to achieve the best class for the M6 index set by the Italian National Authority. Meanwhile, of course, the carbon footprint of the plant was also being reduced by, let's say, 1,200 tons of CO2.
So there's just a very short extract. You can find all of these on our YouTube channel. Now, what I suggest is to get a real look and feel for the solution itself. All these digital tools can seem very difficult to feel. So I'm going to jump into what the tool looks like. And now, so when you log into Hubgrade Performance Plant, each client gets an access to the platform. This is done through a web portal. And within a utility, say that's connected to this, they can administer themselves, the users, their rights, and the amounts, etc. The first screen you jump into is the overview screen, which is a customizable widget screen with the most important information that you would like to have and see there. And so I've set mine up this way, where you can track, for example, your KPI of kilowatt hour per day to see if you're on target in terms of energy efficiency, your compliance, your hydraulic state of the plant. Two things that are important is you've got one, which is the data quality check. Indeed, digital tools are only as good as the data they're fed with. So every data point coming into Hubgrade Performance Plant get checked by the algorithms to see whether they're satisfactory or not and can be used for the optimization. If not, they are sorted apart. They are taken out of the equation. They're listed here, and so you can go and do targeted maintenance for it. Finally, we have this triangle here, which is illustrating the fact that optimization is not the same for all of us out there. Quality, cost, and environment is not weighed the same way in each asset, and thereby each user can customize his objectives of optimization, and Hubgrade will then try and optimize within those boundaries. If we jump into a little bit deeper into it, you can see that, for example, here on this wastewater treatment plant, you have a number of features and algorithms that have specific optimization targets that are listed. The operators of our plants are always the ones who have the hand on the process, and thereby the ability to turn off the system if they would like to revert back to the PLC logic that is always installed there. And they can do that manually by turning it off, pressed here. If we go in and focus on, for example, an aeration feature that's there to handle the aeration cycles for the nutrient removal, you jump into a part of the tool where you can see and analyze all the data that is shared between the twin and the real world with the measurements and the set points generated. So you can, for example, track here your live measurements of nutrients, ammonia, nitrate in a specific biological tank. You can have phosphate also, and you can, for example, check what is the difference between the set point in black of the oxygen, the DO level in the tank that's sent by the Hubgrade Performance Plant, and the real measurement in the tank. The discrepancy always comes from, well, the latency between a real biological system and what comes from a twin. But it shows that the real plant does follow actually quite closely the instructions, and it is able to implement it very well. Finally, a small detail is that every plant is of course different, so there are some restrictions that have to be met, mechanical restrictions, for example. So some parameters are during commissioning entered manually in a collaborative workway of our process engineer and the local operators to fix, for example, phase durations of aeration. So that was a bit of a look and feel here of what the tool is, and if we try and zoom in on a specific case, I'm bringing you here to a plant. This is a much smaller plant than Nosedo previously. That's 1.25 million. Here we're roughly around 15,000 P. We wanted to focus in on seeing, okay, so how does this operational improvement, process improvement materialize? Well, on the first line, you've got the on time of a mixer. So the mixer state, is it mixing or is it not mixing, and is it stopped? The second line is the blower station, expressed in terms of aeration time. So the percentage of time where the blower station is running to provide air to the biological tanks. And finally, we always keep an eye on compliance, so our ammonia and nitrate measurements. And what you have on the left side of it on the time scale is the system running on the local PLC logic. So before the implementation of HPP. And then in the middle, you've got this overlapping area where we are commissioning together with the client the tool. So that the AI and Hubgrade Performance Plant is starting to optimize, sending new set points. We're doing that gradually, the time to fine tune the system before it finds its new equilibrium, which is when Hubgrade Performance Plant is fully operational. And here what you see is that you find a new, much more efficient equilibrium. The mixtures are running 33% less of the time. You can see that on the time where it's on. The blower station is running 63% less than before, where it was running 80 to 100% of the time. And finally, again, this does not come at the cost of the quality of treatment. When looking at the ammonia and the nitrate levels on the last one, you see that the average is approximately the same. So you are not doing that at the cost of treatment. Now, another case that I wanted to show you is in Denmark. It's in the city of Kolding. The utility company is called Bluekolding. They were faced with some very different challenges in terms of needing a drastic increase in the hydraulic capacity of the plants to handle all the rain that falls in Denmark, to be able to reduce their OPEX expenditures. That's about the same for everybody. And finally, very important, to reduce the number of stormwater overflows in their utility, as that was above the legal maximum. And by combining the sewer system with the wastewater treatment plant in this holistic optimization, they were actually able to reduce the amount of CSOs per year by 83%. And they did that by using digital and real-time optimization. So that saved them a capex of 2 million in terms of retention tank construction in concrete, which is also an environmental footprint saving since you're not pouring concrete into the ground. Their plants were able to handle 80% more load in stormwater events, and the overall energy consumption of the wastewater treatment plant went down by 23%. These are just two of the more than 100 cases that we have around the world. Thanks to Veolia's global presence, we are able to support customers all around the world with our digital system, being large or small. As a conclusion, I'd say we're seeing that the entire industry in the market is sitting on a mountain of infinite data that has been very well collected and sorted, etc. But a lot of players are now looking to see, okay, what value can we bring from this? How do we make anything of all these data points that we have in our PLC and our SCADA? And once you can pull the value out of it, how do you translate that into operational improvements? And finally, the last step is, how do you automate it? How do you create real-time optimization? And that's exactly the journey that we're accompanying all our customers in with Hubgrade Performance Plant. And we think that it has such a great thing to bring to the industry, because you can save yourself the OPEX, and at the same time you can actually act for the planet. And that's a really great win-win situation. So I'm hoping that a lot of you are also interested in agreeing with me on that. I would like to thank you for your attention, and I'm hoping that you would like to ask me some questions. I'm very happy to answer it and get some exchanges going. That was it for me. So feel free to ask all your questions on the GoToWebinar chat platform with it, and we can. I'll try and give you my best answer. So the first one that pops up here is, does Hubgrade Performance Plant always require the implementation of additional sensors in the plant? So no. In a lot of the cases, in the two cases I presented to you, some ammonia and nitrate sensors were installed. Nevertheless, this is not needed to be able to reap the benefits of optimization. So you can start by just using your DO probe, your redox probe at your plant, and thanks to the gray box modeling, we can still predict these behaviors of the system and thus provide the optimization. And then you can build over time, adding sensors if you like, to get more and more value to it. So it's very much modular in that way, and you can build as you go. Okay, another one. So I got a question here. What is the facility in the US? Well, the facility in the US is the plant of Liberal in Kansas. I have unfortunately not visited myself, but we're running it in at the moment, and we're doing, I believe, aeration optimization there, as well as chemical dosing. Question in. So I'm curious if you could speak more to the different ML algorithm used in Hubgrade. Do you leverage supervised learning based on historical data or algorithms that learn in real time? Well, actually, great question. It's a bit of both. The whole point and the idea of the model predictive control is that you start building a model, but you don't start it from scratch by just putting X amount of months or years of data and then just learn in real time from that. You pre-train it on data that is relevant, and then you've also fed it with some kinds of ramification that are the heart of wastewater treatment. So that's where VVT's and Veolia's process know-how come into play, is that you can say, okay, I'm not just looking for patterns as a neural network thing would do in any kind of data. I'm looking for patterns inside wastewater treatment to optimize it. So we've got, I think it was pre-trained on 10,000 hours plus of data, and then combined with real time on a real asset before it was kind of ready and robust to go out and being industrialized. And now it's learning through all of the assets that are connected. I hope that answered your question. I see that there's a question about, is it possible to develop virtual sensors with Hubgrade? Yes, you can use virtual sensors with it. We actually apply it through the model predictive control, and in order also to minimize, say that you would like to go and purchase ammonium nitrate probes, well, you can do that, but we don't think that there is value in equipping every single line. So then maybe you equip one, and then we infer through virtual sensors the other line, and the algorithms would then know how to handle that. If that answers your question, that great, or else please feel free to come back with another one. Another one here in the Denmark example, Bluekolding. The system able to predict what weather CSOs? If so, elaborate on the data needed for the system to do that. So on that, I forgot to mention a thing while I was talking. We did a couple of weeks back, a colleague of mine did a webinar on the Hubgrade Performance Sewer part, so the sewer part of the solution. You can catch it on our YouTube channel, so definitely go catch the recording of that one. You'll get a lot more details. But I can give you a couple here, which are it is able to detect the risk of a CSO. So there is a hydraulic model built in to the part of sewer that in real time through rain gauges and through levels and pumps, etc., can see the level of fillage of the different places, and then coupled with a weather forecasting system that we're able to use around the world thanks to Veolia's weather service. Actually, it's then able to compute all these parameters and say, okay, then we're at risk of having a CSO over here. So I will now start pumping from this place to a place further downstream if it's allowed to, in order to minimize that. So again, the whole idea of using real-time optimization for it. I hope that was detailed enough. Thanks, Cole, on the great presentation, by the way. Thank you very much appreciated. See that we have another one. Can you talk about data security? Does operator concerns about that? Well, yeah, definitely. In the age of AI and cloud and everything, data security is paramount. Hubgrade Performance Plant and the Hubgrade platform is inherently built on the most secure, let's say, certificates and IT foundations that we have. We get audited often by third parties based on ISO standards, etc., that we can always show to our customers. I'm not an IT person, so I can't speak too much about it, but we're using OPC UA communication mostly. That is an industry standard for security, and of course, all communications back and forth are encrypted. And if you want to know more about it, I'd be super happy to put you in contact with our IT experts. But it's always a concern, but in a collaborative way, we see that we are always able to set up a system that is secure and that conveys this security and this feel of security to the customers. How much time does it take to make a digital twin for a wastewater treatment plant? We service around, I think it says 20,000 customers. Well, actually, it depends on the size of what you start with. But if you start small, let's say you want to do just aeration, you can be up and running from the start of the project in just a couple months. I mean, the algorithms, since they're pre-trained, as I said before, they can be commissioned within a day or two. So there's a bit of work on setting it up in terms of connectivity and making sure that everybody's on board, doing a good onboarding of the team so that they know how to use the tool. But it can range from a couple months to a bit longer if you're doing some installation of probes, if you would like to. But I give a ballpark, yeah, around a couple months, and then you're up and running from the moment we've scoped the project. So it's quite easy actually to get started. And is Hubgrade used like a yearly subscription? Yes. The way we see, the way we usually do is that there is a SaaS fee, a subscription, a bit like your Netflix account. You pay a yearly subscription to the platform, and then you have access as many users as you want with the service working 24/7, 365. And should we not deliver the performance that we talk about in the beginning, then of course the plant is in this way free of being able to disconnect if they would like to by the end of the year, returning to the installed PLC logic as if Hubgrade had not been there before. So it's an entirely flexible model, and we can of course also accommodate if other setups are wanted. Another question here, just a couple lines. So what if you have other platforms that monitor collection systems such as sewer pressure, flow, and rainfall? Can Hubgrade interface with those existing platforms to use the data? Very good question. Hubgrade Performance Plant, Hubgrade Performance Sewer, both of them are launched on the same platform, so they're essentially the same product speaking together, is completely data technology agnostic. So in that way, whether it comes from one brand of supplier or another that have each their own portal login through the web and everything, it doesn't matter. As long as we can go and get the data through an API or the local GIS or the PLC or the SCADA, then Hubgrade is able to go there and show it and use it in its algorithms. So that's really mostly not a concern unless it's something that's purely manual. But I mean, then this is a digital tool, so it wouldn't need to be digitized. I see. Is the subscription fee based on the size of the plant? No, actually, the subscription fee is not based on the size of the plant. It's based on how much of the product or how much of the service you're getting. You saw in the live example I gave before that they had an array of features and modules and optimizations. So they're targeting more things. This would typically be the main driver in terms of setting the subscription fee. So it's not only linked to the size of the plant. The idea for us is always to have something where both parties are in a win-win situation. Some other questions coming up here. Wet weather operation of wastewater treatment can take most of systems out of optimal normal operation, yes indeed. Explain how Hubgrade can help optimize wastewater treatment plant operation for different levels of wet weather flow. So this can get a little bit technical, but I'll try and make it short. When you're in a wet weather operation or wastewater treatment plant, as you say, you're getting out of your status quo. Suddenly, the type of load that you need to handle is completely different. Maybe in the middle, there's a lot of pollution and a lot of water, but afterwards it becomes mostly flow and not so much load. And the idea is to take advantage of that dynamic inside it. So could you, for example, move some sludge from your secondary settler into your biological basins, and then you could turn off the air in a part of it doing aeration tank settling? Then you would, in essence, be able to alleviate your settlers of an amount of sludge already there, stabilizing it in your biological lane, and freeing up this extra hydraulic capacity. And this becomes especially strong when you're able to predict when the water is going to hit you. So if you've got a weather forecast that tells you in this amount of hours, you're going to have this much flow coming into your plant, then you can kind of prepare in advance your plant by moving the sludge around, turning off the aeration, turning off the mixing, so that you don't create unnecessary turbulence inside your biological tank that could cause a potential sludge escape. So that's a bit how we try and handle it. It's using the dynamics and the forecasting abilities of Hubgrade Performance Plant and Sewer to better handle the overall load inside your asset. What is the price for 1 year subscription, for example, for minimal aeration? Well, it's just on standing for that, it's a bit difficult to just give it, but couple thousand euros, I don't know, between 5,000–10,000 euros, probably around, maybe even, yeah, 5,000 to 10,000. It depends a bit on the asset, you'd have to look, but you're in that ballpark. Who are your competitors to this type of products? That's a good question. Well, there are two types of competitors out there. I could describe. There are the inherent wastewater and water treatment experts that could have similar products. Most of them will be based on systems that are rule-based, white box, as I explained in the beginning. So, you know, providing a kind of system on site that feeds the PLC with some add-on code that's a bit smarter, most open valve, DO control, etc., based on the know-how of that company. So there's that segment. And then there's the other one, which are enabled by the fact that the barriers to entry to digital are breaking down, and I think that's a good thing, pushing the industry forward. So you've got all the native AI people saying that, well, I've got my neural network system, I'll just get it to crunch all the data, and then I will tell you, do this or do that. And while I think that's really good, because it it makes this type of technology enter a rather conservative market. It pushes it forward well, but in my opinion, I think it lacks a little bit of this process expertise, because it's not just a commercial optimization of costs. I mean, the purpose of wastewater treatment is compliant effluent concentrations and nutrient removal. So it's great to apply AI because it can solve and help you do a lot of stuff, but working that into it can maybe be a bit the difficult part. And I mean, there could be a ton of players entering on that way. So I'd say those are the two types. The last one could maybe be sensors suppliers and third parties that come with their own system. I've got a couple more coming in here. Can you give a range of subscription? Are we talking about 1, 10, 100K? I think I somehow answered that before. Is Hubgrade using the same sensors as SCADA, or are they totally different? No, exactly. It's using all the sensors that are there. I wouldn't really get the point of having to install a completely separate parallel system. with it. No, we're completely technology agnostic. The idea is what is in place can be used, and then with the know-how we have on Hubgrade Performance Plant, we make the best of it. So indeed, we take what's on the SCADA, what's connected, what's live, and then we use that to the best of its extent. 5-10K euros per year. Well, that's depending on the amount of features, etc. With it, but I'd say 10K euros per year. 15K euros. I mean, it depends on 5, 10, 15. It depends on a lot of factors. But I'd be really happy to if you other guys have some questions about that. It's completely free to come and talk to us, and we can do a little check and look at a specific asset together, and super quickly we can give you a tailored price for you. Is there any installation fee? Well, I mean, if we're aiming at the same one, minimal aeration setup, no. Then the idea is to go with a no capex setup. This is a service that a digital service that we're offering as a SaaS. Nevertheless, if the business model that's more adapted to it is something with some capex, then yes. But the idea is that we really try and run on what's there, and thus have a no capex SaaS fee setup. Do we have a couple of others here? So there's an last one coming also is what are the typical ranges of wastewater treatment plants you're working with? So I showed you before. We have customers that range down from 2,000 PE to 2 million PE. So it's very broad. I would say that most lie in the vicinity of, let's say, 10 to 50,000 PE. If there are any of my acquaintances and colleagues and everything in the US, I'm sorry for not being able to translate that into MGDs. But yeah, I would say it's in that size. But yeah, as you saw, we also have these large assets, and essentially you can do digital twin and Hubgrade Performance Plant on any kind of asset. Smaller ones that just want to start with aeration, really, start their process optimization journey. Then you got the larger assets that are perhaps already a bit further down that lane with the resources available, that are looking to fine tune a little bit more their process in terms of dynamically opening and closing a line, introducing biological phosphorus removal, like Milan talked about, or mid-sized utilities that are looking into this CSO thing by coupling the sewer network together with the plant. Well, yeah, I think that's about it for the moment. I hope. But we have one last coming in. Does Veolia assess and recommend where to start? What areas should be focused on for the specific plant? Yes, of course, we do. We love to speak with everyone out there and kind of get around the table and work on this in a collaborative manner. So the idea is that we take a look at the asset, some rather basic parameters in the beginning, listen to you first and foremost. So, what are your challenges? What type of solutions are you looking for? Where do you want to make an impact? And then together we try and build something of a digital twin, a Hubgrade Performance Plant package, say, that's fitting for that. I think that on that note, time is flying, but I would like to thank you all again for participating. I hope that this was an instructive session. So please feel free to get in touch with me or any of my colleagues that you might know if you want any additional information. You'll all get the recording of the webinar if you want to share it with a friend or with a colleague or with a peer. And we really look forward to hearing from you and embarking on this digital journey together. Thank you very much for your attention, and have a nice day.